Alrighty, so this is the Unit 1 video, chapters 1 through 3. And here are the problems I've written out, and I'll explain here everything that I've done. So for the first question, we're converting 0.045 grams into micrograms and showing your work to figure out how we got it. So first what we need to know is the grams, we got right here, and then the conversion from grams to micrograms, which is 1 gram equals 1,000,000 mcgs. And then I just took the basic dimensional analysis here equation, which is 0.05 over 1 times 1,000,000 mcgs, and then we got 45,000 mcgs, and you just got to cross out the grams, and that's how you decide mcgs that you got. So the first one was pretty cut and dry and simple for how to get that. And then let's go to number 2, and we're pretty much classifying these 4 different types of categories into an element compound, homogeneous mixture, and heterogeneous mixture, and explain how you got those. So for the first one is chicken noodle soup, and that is a heterogeneous mixture. It's not uniform. It contains different objects like broth, noodles, chicken, etc., and it's made of 2 substances that do not mix well together. So that one is the heterogeneous one. And then for B, you got oxygen. I mean, that's just straight up an element out of the periodic table. It cannot be decomposed any simpler, so that one's very straight and cut forward. And then going to C, you got sugar, which is a compound, and that one is C12H22O11. So that one was pretty simple to find out. It is made up of 2 or more elements using the definition of it. And this one's made up of 3 elements that are bonded, which is carbon, hydrogen, and oxygen. So that one was pretty simple to figure out. And then lastly, for D, you got air, which is a homogeneous mixture, and it's made up of various elements and atoms. You got nitrogen, oxygen, argon, CO2, and others. And by definition, this M cannot be broken down physically, which in definition explains how or what a mixture is, basically. So every single one of these 4 was one of the 4 different classifications. Next, we're going to go to 3 here, and we're working with hydrogen. And the first part of it was, is there 1 atomic number possible for H? And that is yes, because only 1 particle in the nucleus equals 1 proton. And then after that, what else are there? Was atomic numbers for H? And atomic number is 1, like I said. The sum of atomic particles is 1 proton, 1 electron, with multiple possibilities. The mass numbers for hydrogen are 1H, 2H, 3H. Those are all possible isotopes. And how they get those is pretty much have 1 proton, 1 neutron, and then the 2H, you got 1 proton, 2 neutrons. 3H, you got 1 proton, 3 neutrons, etc. And then for the very end there, if there are 2 atoms or elements with different mass numbers, what are they called? And that's one vocab terms, and that's an isotope. And that was pretty cut and dry into the book. And then we're going to go to number 4, the ionic compound of CuSO4, copper sulfate. And what is the cation of this compound? And that is copper cation with a 2+ charge. And then the anion at the end there is the sulfate anion, which is a 2 negative charge. The name of this compound is copper sulfate. Sulfate because it has a 2 ion charge, negative 2 ion charge. And then the molar mass of this one, pretty much just taking the atomic mass of the 3 elements. So for copper, it was 63.546 grams per mole. Sulfate, 32.065 grams per mole. And then oxygen was 16 grams per mole. And you can see that there are 4 atoms in this equation. So you take that times 4 and you get 64. Add everything up and you get 159.6 grams per mole. So that's everything for number 4. Number 5 one was an interesting one. We're using NH3, trying to form a Lewis structure for ammonia. And how we did that was first you got to find the valence electrons. Nitrogen has 5, helium has 1. We take that times 3 because we got 3 there. So we got a total of 8 electrons there, or yeah, 8 of those. So first we draw out the neutrons, draw out nitrogen, draw out the lines to hydrogen, and then you got to have a total of 8. So each line represents 2, 2, 4, 6, and you add these 2 up here because a total charge of 8. And then we're going to go to B, the molecular shape of ammonia, and that is a trigonial pyramidal, if I'm pronouncing that one right, 107 degrees. Why? It has 1 atom at the apex and then 3 atoms at the corner of the same context. And then what would you expect ammonia to be, polar or nonpolar? And this one's polar. There's a large difference in the electronegativity between hydrogen and nitrogen, hydrogen at 2.2, nitrogen 3.04, along with an asymmetric shape and uneven dispersion of electric charges. So all in all, this is 1 through 5 that I have on here. Here is my work that I have shown. I'll flip through these again just to make sure. I apologize if I'm shaking. There's 3 and 4. And then you got 1 and 2 here. So everything was good. It all worked out. And yeah.